Hi class, let's take a look at example 4a, and they are asking us to verify that the lines are parallel. So this one is actually simple. We can actually define the direction vector. So let me just say define v1 as, in this case, 2 comma negative 3, negative 1, and the values of 3. And v2, which is a direction vector of the second line, which is 4 comma negative 2 and 5. Now, the lines are going to be parallel if you have the same direction vector. If they don't have the same direction vector, in this case, your lines are not going to be parallel. So this one, we can just note, let me just say note the values of v1. It's not equal to kv2, and this is because, well, your third component, which happens to be the z's, they're not equal. You're not able to rewrite it in any form such as a constant multiple. So it works really nicely on the first two, but not on the actual third one. So in this case, we would say, no, the lines are not parallel since the vectors are not parallel. I'll just say the lines are not parallel since the direction vectors are not parallel. And then if they want more explanation, you can simply say that, well, 2 times v1, this is equal to 2 times the vector 2, negative 1, and 3, which is equal to the vector 4, negative 2, and 6, which is not equal to the vectors of v2. Remember that your vectors are parallel if they're constant multiple of each other. And in this case, this one's easy to spot because your first two match and the last one doesn't match. And just to be super clear, referring to the third component. When you multiply it times 2, you're not going to get technically the z value. So in this case, yes, this is actually it. We don't have to go further. Since we don't have the direction vectors, your lines are not going to be parallel since the direction vectors are not parallel.